Welcome to Robotic Learning at the Edge, insights from 13 new papers. Today, we spotlight breakthroughs in data-efficient adaptive robotics, as featured in the arXiv preprint server's cs.RO community. This episode highlights key advances in learning from less data, multimodal perception, and adaptive planning, with a special focus on Omkar, Patil and colleagues' work on factorized diffusion policies. Join us to discover what's next for intelligent, safe, and robust robots. Did you know that, on average, factory robots process less visual data in a year than a smartphone camera does in just a single afternoon? Despite this, these robots are entrusted with critical adaptive tasks, often relying on minimal data streams. Imagine a future where robots could instantly learn from a handful of video clips or a single touch. Recent research is rapidly bridging this gap between scarce data and robot capability. In this episode, we explore how this leap in robotic learning is unfolding. Today, we examine 13 new research papers, all converging on a transformative theme, enabling robots to become smarter with less data. Robots are now learning from videos, sparse signals, and a variety of sensory cues. These innovations span a range of environments, from factories to hospitals and homes. Our journey traces the evolution from limited sensing capabilities to robust, human-like learning. Stay with us as we unpack these breakthroughs and discuss their real-world impact. The field of computer science, robotics, or cs.RO, serves as the orchestra pit for robot intelligence, harmonizing diverse components such as vision, touch, motion, language, and control theory. Each element acts as an instrument, building bridges between seeing, feeling, and moving. This foundational research powers technologies in automobiles, industrial automation, assistive devices, and planetary exploration. Every advance in cs.RO becomes a new plank in these bridges, expanding the reach and reliability of robotic systems. Theme 1 is data-efficient robot learning, as explored by Jingxi Xu and colleagues. Robots frequently learn from sparse, incomplete demonstrations, akin to teaching a child to ride a bike with just one demonstration in darkness. Innovative strategies have been developed to extract the maximum possible value from minimal data, such as gleaning insights from a single touch or a rare biosignal. This sets the stage for deploying robots more broadly in real-world scenarios, even when data is scarce. Theme 2 addresses multimodal perception and observation prioritization, highlighted by Omkar, Patil, and team. Robots must balance vision, touch, and proprioception, much like a chef relies on all senses in a busy kitchen. Factorized diffusion policies now enable robots to shift their attention dynamically, adapting to the demands of each task. This robustness to sensor failures, such as when one sense is blocked, prepares robots for unpredictable and complex environments. Theme 3 focuses on learning from human videos and demonstrations. Robots are now capable of extracting skills from ordinary human-centric videos, eliminating the need for expensive motion capture systems. Frameworks such as HDMI and Kung Fu Bot 2 enable robots to learn object interaction and movement by observing video clips. Real-world experiments show robots performing new tasks after watching these demonstrations, analogous to learning Kung Fu by watching martial arts movies. This unlocks scalable, low-cost training for complex robotic skills. Key findings from today's papers offer compelling mini-stories from the robotics frontier. Patil et al. Demonstrated that factorized diffusion policies yield 15% higher success rates with limited data and a 40% improvement when sensors fail. The HDMI framework enabled robots to learn new tasks from everyday videos, successfully opening 67 doors and mastering 14 simulated tasks. The smart 3D algorithm granted robots agile, real-time navigation, eliminating the need for slow, grid-based planning. TranTac achieved 88% success in tactile-only insertions, even with unseen objects. Finally, No Real 3D demonstrated object manipulation from single two-dimensional images, rivaling the performance of costly three-dimensional sensors. The featured paper of the day, by Omkar, Patil and colleagues, addresses the central challenge: determining which sensory input a robot should trust in real time. Traditional approaches treat all sensory data equally, but Factorized Diffusion policies, or FDP, introduce dynamic, context-driven sensing. Imagine a robot chef who closes its eyes and relies on touch when vision fails. FDP allows for this kind of flexible prioritization, setting a new standard for robust, adaptable robot behavior. Factorized diffusion policies deliver tangible, real-world benefits. Robots utilizing FDP outperform conventional methods when data is limited or sensors malfunction. Specifically, FDP yields a 15% improvement in task success under data scarcity and a 40% boost when sensor disruptions occur. These robots adapt on the fly, seamlessly switching to the most reliable sense available. This adaptability is inspired by human behavior in kitchens and workshops and is crucial for deploying robust robots in homes, hospitals, and factories. Behind the scenes, the development of FDP stemmed from the team's frustration as robots routinely failed due to minor sensor glitches. Lab brainstorming sessions led to the pivotal idea: if only robots could close their eyes and use their hands. The factorized approach enables robots to tune their attention much like humans do. This breakthrough, achieved through collaborative problem-solving and late-night coding sessions, paves the way for selective attention in robots and enhances their safety in real-world deployment. Looking ahead, the field is moving toward democratized, imaginative robots capable of learning by watching, feeling, and listening, mirroring human adaptability. Integrating deep learning with formal safety guarantees is creating robots that are both trustworthy and creative. Generative models empower robots to imagine, plan, and act with increased flexibility. Soon, teaching a robot may be as straightforward as showing it a simple video. The analogy is clear. The journey ahead resembles climbing a mountain, challenging yet offering breathtaking new vistas. In conclusion, robotics is entering a new age defined by data efficiency, robustness, and increasingly human-like learning. Research by Patil et al., Jingxi Xu et al., and others is driving advancements that make robots safer, smarter, and more adaptable. Challenges such as sparse data, unreliable sensors, and the simulation-to-reality gap are being systematically addressed. The next generation of robots will be not only adaptable and safe, but also more creative and accessible. Listeners are encouraged to explore, share, and participate. Their curiosity is essential to ongoing progress. This episode was synthesized using GPT 4.1 from OpenAI for summarization and narrative construction. Text-to-speech capabilities were provided by OpenAI, with planned visuals generated using Google Image Tools. All synthesized content and references underwent expert human review, though minor oversights may remain. Listeners are advised to consult the original references for full details. The works featured include those by Patil et al., Jingxi Xu et al., HDMI, Smart 3D, TranTac, No Real 3D, and others. If you're passionate about robotics and AI, subscribe to AI Frontiers for more deep dives and research breakdowns. Stay informed on the latest advancements in artificial intelligence and robotics. Listeners are encouraged to share, comment, and suggest topics for future episodes. This is AI Frontiers. Thank you for joining us at the leading edge of technology. In this podcast, we bring you the latest breakthroughs in computer science and AI. Straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.